in the sketch alongside, right, which is this sketch over here. O is the center, so there's O over there. And then it says, yeah, O is the center of the largest circle. And then it says AB is equal to BP, and it is equal to PE. And then it says here, AD, wait, oops, AD is parallel to FE. So these are parallel to each other. Now, the one thing I can honestly say up front is when I'm looking at these questions and when I'm looking at this sketch, the only thing is it's not as though I know the answers or like I have some fancy way of like figuring stuff out or anything. No, to be honest with you, the only thing that I can safely say I maybe have is maybe some form of confidence to maybe say it may get hard, but we'll just try and figure something out. I think that's the only thing with Euclidean geometry. With Euclidean geometry, you do want to be a bit confident in yourself, and you want to almost not feel too suffocated by the questions, as I feel suffocated now, because it's like, dang it, bro. But don't worry about me, to be honest. If my voice feels like it's like going away or whatever, like I'm really not dying. It's just my voice. Like I have all my energy and my health is fine. It's just my throat. So it says here, prove that ACD, where's ACD? We're talking about A, C, and D over there. So there's this triangle here that they want us to work with. And then they also want us to work with triangle EPF. So EPF, let me maybe use a different color. So there's E, P, and F over there. Okay. So before I like carry on, right, the one thing I want to re-emphasize with Euclidean geometry, which is something I don't think I have emphasized well enough, is this acronym, Dr. Cape Town. You see, Dr. Cape Town. So this word, the acronym you can always remember is DRCPT. So if you want more info on Dr. Cape Town, the link to that, I mean, it's basically a strategy that you can always use when you go through Euclidean geometry questions. So my assumption is what I'm referring to, but if you don't, let me just give you an idea of where this is. So if you go on playlists and you go down to Euclidean geometry, around, where is it? Video number 11, you're going to see a strategy to approach Euclidean geometry writers. So the idea with the acronym is it basically gives you a way to like target different things in your sketch that you can use to then help you answer your question. So the D stands for things like diameters. If you have a diameter in your sketch, then that's going to be useful in some way because you do have a theorem that deals with the diameter of a sketch. You see, that's what the D there stands for. You see, the D there stands for, why am I writing with black on black now? The D there stands for diameter. So I'm not going to go too deep into this, right? Because as mentioned, there is a whole tutorial on that for that. So whatever we're going to use here, I'll mention it. So in this sketch, we do have a diameter here, but it doesn't look like this diameter is part of any triangle. We also do have the radius of the circle. R here stands for radius because, whenever you have a radius of a circle, that's quite useful. But so far, it doesn't look like this radius is going to do us much. C here stands for cyclic quad. We don't necessarily have any cyclic quad anyway here, but we do have one in this other circle. So in this first circle, we have nothing, but in the other one, there's a cyclic quad over there. So we may not end up using this cyclic quad, but it's just something to take note of to say that, okay, fine. As long as you can remember this acronym, it helps you to look for specific things in your sketch. And then C here stands for parallel lines, of which anytime you have parallel lines, you want to think of fun, because you'll have corresponding angles and you'll have other stuff like that. Like for example, here already we're seeing here, you have corresponding angles over there. So if you ever need to work with those, you already know that they're there. And alternating angles, I mean, like if you have them, if you ever need them, I mean, like you can always remember that. And then the T here stands for tangents. You see, so here we don't have any tangents. So here we can almost forget about the T here. So me having to have said all that I've said, it's almost like a way of me reminding you that when you're going to work on Euclidean geometry, this should be like at the top of your head before you start. And it's going to come automatically over time, you see. So for our question, they are asking us to prove similarity. So proving similarity is really not an issue. It's one of the easiest things you'll ever have to do. But then from proving a similarity, everything else comes after that. So proving similarity, firstly, the two triangles that you're going to be working with, right? The big idea that you want to keep in mind up front is that the question itself already gives you what you should start with. So here we said this symbol means similarity. Secondly, if this symbol means similarity, they want us to prove that this triangle is similar to that one. Now, the good news is if you're ever going to prove similarity, all you need to do is to prove that two angles are equal, right? And then the idea is the third will automatically be equal. You see, so this is almost to try and make your life easier, because with similarity, obviously you need to prove that three angles are equal, right? But then in terms of you actually looking for something to write out, just look for two, you see, two pairs, because the third one, you will automatically always be able to say they are equal because of interior angles of a triangle, you see. So we're going to show that in practice while we're going to be working on on the question that we're going to be working on now. So that's the first thing we can say up front. This means similarity, and we need to just find two pairs of angles that are equal, and then the third ones will automatically be equal. So me having to have said what I've said here, the last portion of information that we need to mention is that in terms of you showing that two of the angles are equal and then eventually showing that the third one is equal, all you need to do is use your question to help you to figure out which angles you should target. So this is what I mean. If you look at your question, right, your question already gives you what you should target. Like here, your question is literally telling you in triangle ACD, which is ACD over there. They're already telling you that A for that green triangle is equal to E for the red triangle. Just the way this is written out, they're already telling you which angles are equal to each other. You should just prove it. You see, like here, the next one, the C here in this triangle, they're trying to tell us that it is equal to the P in the other triangle over there. And then it goes also for the last letter over there. The D in this triangle here is equal to the F in this triangle over there. You see, like the way your letters are written out will always tell you exactly which pairs of angles you should prove to be equal. So in this short space of time, right, you can see I haven't even dived into the question yet, because I'm just trying to show first things first. You see, as long as you can get these mini basics out of the way to say that, okay, fine, if I need to prove similarity, it's just a matter of finding two angles that are equal, and then the third ones, they're automatically going to be equal. So when I say just find two, it's a matter of picking which two are the easiest ones to show that they're equal. And then the third one, you'll just say it's equal because of interior angles of a triangle. So with all that I've said now, all we have to do is to just put it in practice, you see. So for question one, if you're going to prove similarity, you can firstly just mention which two triangles you're working with, even though they've asked it. All you have to now say is in triangle A, C, D, right? And triangle E, P, F, in these two triangles. Firstly, let's look for, let's try and see what we can do. So before you start, right, we said pick two pairs which are easy to prove that they're equal. What I mean is you're going to look at A here and E, and then you ask yourself, okay, fine, looking at where A is over here, right? Let me actually color code it the way we did here. Looking at where A is, because remember, it's like they've given you the answers already. You just need to find reasons why they are equal, literally. So here already we know that there's A over here because there's A written there. And then here there is E for the other triangle. So we know that just from the way they've written this out, they're telling us that we should find a reason why A is equal to E. Now, just looking at it like now, if you're going to find a reason why A is equal to E, don't look for a theorem that's going to directly link these two angles. You see, that doesn't work. What you want to do is, firstly, you want to ask yourself, what is E equal to? And then what is A also equal to? Because as long as you can find something equal to E, or you can find somewhere equal to A, you can eventually link these two together. So before I even carry on, right, can anyone see any angle that is equal to A? And can anyone see any angle that is equal to E? Just from looking at our sketch, because we're looking for something equal to A, we're looking for something equal to E. So if you see it, now is the time to, you know, put the mic on and be heard. And if you have any questions, that is also now is the time to ask. Let me see. Someone said anything in the chat box? Nope. Nothing in the chat box. Wait, let me see if mic's also off. Yeah, so which other angle is equal to A that you see on the sketch here? And which other angle do you think is equal to E on the sketch here? Just by looking at this image. We need something equal to A, and then we need something equal to E. So does anybody see anything? We shall wait. Just a few seconds, I guess. Let me maybe zoom in. Or let me maybe give some hints. ABP is an isosceles triangle. And then we also spoke about parallel lines, because we have AD parallel to FE. So that's another hint. So does anyone see any angle that's equal to A, or any angle that is equal to F? I mean, like, don't be shy, you know.
Yes.
Like if you pardon?
Sorry.
Yes,
Yes, angle P3 it's equals to A.
And then the reason?
Angles of two equal sides.
Yes. Angles opposite equal sides.
Opposite,
That's
yeah.
gonna be, yeah. So angles opposite equal sides. So let's write that down. So the first thing is we've shown that A here is equal to the E. No, we haven't yet. We're just getting there now. So let's firstly say angle A is equal to P3. The reason is angles opposite equal sides. And the equal sides we're talking about, they already gave it to us. You see, they told us, so we can just immediately start writing out our reasons. Now, what else is equal to P3 in our sketch? Let me even try and make it, you know, as clear as can be. Like, what else is equal to P3?
E. Angle E.
Yeah, you see, because you literally want to just take the hints from the question, because the moment you have found something equal to A, né, just see if that same thing is equal to E as well, you know, just find a reason. So for example, now we have found our reason, right? So let's see here. What are we gonna say? P3, E is equal to P3. The reason will be corresponding angles. Yep, corresponding angles. That's the reason why those two are equal to each other. Cool. So now that we have shown that they're both equal to P3, we have easily shown that they're equal to each other, you see. So now we can say, therefore, A is equal to angle E. So now for our triangle, or rather our two triangles, in terms of us proving similarity, these two are sorted, you see. We can just move on to the next set of angles that can work. So in terms of you moving on to the next set of angles, you just want to choose wisely. Just choose something that looks like it's going to be easier to prove, you know. So for example, with C and P, I mean, one way or the other, right? P, because of our theorems, what is the size of P? Does anyone know what the size of P1 is? Oh yeah, because I was saying P, I meant to say P1.
90.
Yep, 90. P is equal to 90 because of theorem 1. You see, because remember, theorem 1 literally says a line that passes the center of a circle, if it bisects a chord in half, then it means that it bisects that chord at an angle of 90 degrees. So just by looking at our sketch, we can already see that P1 is equal to 90. So we already know that this P1 is equal to C, right? But then the issue is it's going to be a bit difficult for us to show that this angle is equal to 90. But I don't think so, actually. Actually, let's use C and P, because I just saw something that is going to help us, you know. Because remember, we said always use your letters in your question to help you to see which ones are equal. And then you should know they're equal. You should just find reasons why. So we know this is 90, and we need to find a way to show that this is also equal to 90. Now, this is what I would do. Remember, we said we know this is 90. We need to find a way to show that this is 90. Now, the big idea with this is whatever you're gonna think, firstly put it on paper before you end up just using it without giving your reasons and all that. So firstly here, P1 is equal to 90, and we're gonna give our reason. P1 is equal to 90 degrees. The reason here is, or rather, before I even carry on, let me give you the big idea of what we're doing. So we're going to show that this is equal to 90, right? And then we're going to show that this is also equal to 90 because of vertical opposites. After showing that this is 90, we are going to show that this plus this has to add up to 180 because of opposite angles of a cyclic quadrilateral. Because you see here, that cyclic quadrilateral we once spoke about in the beginning. Remember, that kind of information goes into your subconscious. So even once you're now working on the question, your brain is able to remember that, okay, wait a minute. I mean, if there's an angle here, and I want to show that this is 90, the link is here, you see, because these are vertical opposites. So this is 90, this will be 90. Now, because these have to add up to 180 because of a cyclic quad, that's the way you can now eventually say this is 90 as well, you see, because with Euclidean geometry, it's more like a trail, you know. You just have to follow the trail until you have the answer that you're looking for. So now let's follow these steps one by one and put them on paper. So we said P1 is 90. Our reason is line from center of circle. You know, that's literally what you're going to say. Line from center of circle. There you go. So now you know why this is 90. P4 being equal to 90 is also relevant because we already stated what we're going to use it for. So P4 here is 90. The reason is vertical opposites. You see? So that's why this is 90 as well. Now we need to say that P4 plus C should add up to 180 and give a reason. So P4 plus C is equal to 180. The reason is opposite angles of a cyclic quad. Opposite angles of a cyclic quad. You see, so once you've done that, automatically you know that if you want to solve for C here, this is 90, you already worked it out. C you don't have, but then solving for C here, you're going to now end up with C being equal to 90 degrees, which is what you actually wanted in the beginning, you see. So let me just end this question and then I'll add Valencia so that, okay, let me just add her now. And then I'll just carry on and then we'll just bring her up to speed later so that we don't get interrupted. Let me see if there's a question here. Chat, Amy, P3. Oh, anyways, so moving from here, and then what you can see is we have shown that two pairs of angles are equal to each other. You see, we showed A is equal to E, and then now we have shown that C here is equal to the P over there for that triangle. And then now you're home free. The reason why I'm saying now you're home free is because for the third for the third angle, literally 90% of the time, your reason for saying that they are equal, you will just have to say interior angles of a triangle. Because you see here, this angle here, which is the F here, right? It is equal to the D over here. You see, because this F here is equal to the D over there. So we're gonna say they are equal because of interior angles of a triangle. The reason is, remember, if two angles of a triangle are equal, the third one is automatically equal because they always have to add up to 180. So that's what we're going to say for for F and for D. So here, angle F is equal to angle D. The reason is interior angles of a triangle. You can only use this reason once you have shown that two angles or once you've shown that two pairs are equal. You see, because if you have shown that two pairs are equal, the third one, now you can use this reason. You see, it doesn't make sense for you to start with this reason. It only makes sense if you end off with it, because now if you look at our three pairs of angles, there's this one here, and then there is this one here. I think this was the beginning, A and E actually. The second one was where is it now? Where's the second? The second one was C. What? I think here I didn't finish, did I? Oh, yeah, I forgot to put the conclusion here. Because when we showed that C was also equal to 90, our conclusion here should have just been, therefore C is equal to P1, which was our goal in the beginning. So we did everything, we just didn't put the conclusion. So you see three pairs of angles, 1, 2, and the third one's there, you see. So as long as you've shown that three pairs of angles are equal to each other, then you would have proven similarity, which is what we have just done here, you see. So your conclusion here will then be, therefore, triangle ACD is similar to triangle EPF. And then you're done.